In this example, we have let z equals -2 plus 2i squared root of 3, and we're going to find the value of z to the third power. We'll represent your answer in complex polar form r cis of theta, and in rectangular form a plus bi. We're going to simplify any trigonometric expressions. So, if we do want to take this to a power, we should probably be using the power rule, which means that we need to convert this number, which is currently in rectangular form, into complex polar form. It is possible to take this complex number to the third power as it is in rectangular form, but it will be a little bit simpler in complex polar. So let's do that. First though, let us quickly find z in complex polar form by evaluating the modulus and the argument. The modulus of z here, using the Pythagorean theorem, would be -2 squared plus 2 square root of 3 squared, all under a square root. This one will come out pretty nicely. -2 squared is 4. 2 square root of 3 would be 4 times 3, which is 12. 4 plus 12 would be the square root of 16, which is just 4. The argument, on the other hand, for z, do keep in mind that our complex number there, -2 plus 2i were 3, that has a negative real and a positive imaginary, so that means we're expecting an angle measure in quadrant 2. If we work with arctangent of the imaginary component 2 square root of 3 over the real component -2, we will need to adjust the angle measure accordingly, as arctangent would not directly give us the angle in quadrant 2. This would actually give us an angle measure in quadrant 4, and we would need to add pi to adjust correctly. If I do evaluate arctangent of, in this case, negative square root of 3 over 1, well, arctangent of negative square root of 3 over 1, that would give me sine over cosine, that would give me negative pi over 3. And then if I add pi to that, we get the argument of 2 pi over 3. Meaning I can write z as the number 4 cis of 2 pi over 3. So we have taken z and written in complex polar form. That way we can more easily take the high power of this complex number. In this case, just to the third. But in order to apply the power rule or de Moivre's theorem to this, if we're taking a complex number to a power, de Moivre's theorem says take the modulus to that power, and then multiply your angle measure by that power. So in this case, we're going to take our modulus, which is 4 to the third power, and then we're going to multiply our angle measure of 2 pi over 3 by the value of 3. Well, 4 to the third power, that would equal 64. And then 3 times 2 pi over 3, that is just 2 pi. We have now written this in complex polar form, r cis of theta, but it also asks us to get to rectangular form, so we can expand in order to get there. Cis of 2 pi really means cosine of 2 pi plus I times sine of 2 pi. And if I distribute 64, I can find this as a plus bi form. We also should not need a calculator for this because we can also evaluate cosine and sine of 2 pi. Cosine of 2 pi I know would equal 1, so this would be 64 times 1. Whereas sine of 2 pi, that would be 0, so that's 64 times 0. Or, because that's imaginary part of the complex number would equal 0, we just have the answer to be 64. This would be acceptable as a value in rectangular form a plus bi form, but if you prefer, you can also write this as 64 plus 0i. That would also be sufficient.